that he was talking about right outside, and I can only advise you to give it a try. It's really mind-blowing. It's really incredible. Okay, on to the next topic, which is very, very similar to Peter's. I'm going to be discussing swept source OCT A Enface choroidal vasculography to see if it's possible to actually visualize the choroid in a different way using the data that we have in swept source OCT. So you obviously saw before that a lot of my research is involved in creating three-dimensional reconstructions of swept source OCT data. And I also, of course, create three-dimensional reconstructions similar to the ones that Peter was making because I think that we can use these kind of reconstructions to do volumetric analysis of the lesions and see how they grow and how they shrink. But in order to do anything about the choroid, we have to have bigger images because the choroidal imaging needs to be a lot larger than the 4x4 or the 6x6 millimeter scans we were using. So I waited until we had the 9x9 millimeter scan, which has 512 A scans by 512 A scans, and you can put them together to create a mosaic. And with this mosaic, it's then possible to get a lot larger scan areas than you could before. And I wanted to see, is it actually possible to visualize the choroid using that? So you could, what I also did is I took the three-dimensional mosaics, and it's possible to create a three-dimensional reconstruction of it. So here you have a proliferative diabetic retinopathy. And in the three-dimensional reconstruction, you can see all of the small details. In here, you've got the ischemic areas, you've got the proliferation of the disc, and of course, you have all of the erymas and microaneurysms and so on and so forth. Now, the question that I had was, is it possible to create, using the data from the OCTA, to get some kind of information of the choroidal vasculature? Now the question that came up, is it possible to do an OCT angiography of the choroid? And the answer is, quite frankly, no. And if you looked at my previous presentation, the reason for that is quite clear. If you have your laser going through the choroid capillaris, and the choroid capillaris is a very, very dense carpet of moving cells, and it throws a projection artifact on everything beneath it, you end up with a lot of noise and a lot of movement artifacts that the algorithms can't differentiate. And that is wavelength independent. With the Triton wavelength, we can penetrate all the way down to the sclera without a problem, but we can't get rid of all the noise. But what I was looking at was I took a look at the segmentation of the choroid. I went down with the choroid capillaris part, and I went down into the choroid, made the slab a little thicker, and I inverted the image. And when you do that, you suddenly get these areas that in the normal image are dark. These images are suddenly white. And they start looking very, very familiar, and they start looking very, very close to an image you might see in an ICG. So I took this proliferative diabetic retinopathy, and I did a fly-through that goes through the entire scan one by one, and you can see that this is truly getting it's able to visualize the choroidal structures in a way that we weren't able to before. Now, the very important thing to realize here is that what you are seeing here is not flow data, it's structural data. Because I found out that if you, instead of using the OCTA data, you actually use the structural data inside the OCT, which is inherent in the OCT anyway, and you invert it and resegment it, then you can suddenly get all of these vessels very, very clearly. With the new software, it's obviously also possible to create very, very large mosaics so that you can get a very, very large area to scan. And when you then take the inverted structural data and look at the choroid, you can see a lot more information over a much larger area. Again, it's very important to realize that this is not showing flow, it's showing structure. But okay, this is all very interesting, but in order to see what we're really seeing, we need to compare it to ICG, because this is the kind of stuff that we can previously image using ICG. So I took a patient. This is a patient with CSCR and a secondary CNV, and I did the FA, and then I did the OCTA, and you can see a lot of details in the OCTA. You obviously can't see the leakage. And on the same patient, I did an ICG. And if you look at this ICG right here, and you see all of the small vessels, you see all of the larger vessels, you see everything that's going on in the ICG here, and you compare it to different layers of the structural OCT, visualization of the choroid, you can see that there is none of the vessels in the ICG that are not visible at some point in time in the structural OCT. The main difference between the two is that here we have depth resolution. We can tell at what depth these vessels are, and that you can't do in the ICG. So you actually have more information. But just like OCTA, one of the drawbacks is, of course, that you can't see leakage, which isn't possible in this case. But we have a lot of information. So in order to highlight that point, I again did a fly-through, and you can see when you fly through all of the different layers, you can see that when it starts on the top, you see the smaller layers of Sadler's layer, and then the smaller vessels of Sadler's layer, and you can slowly focus down into Haller's layer, and you see all of the information that you were looking for. Oops, sorry. Just like Peter, it's possible to take that information and to create a triangle mesh segmentation of it, just like I had done with a choroidal neovascularization. So in this case, this makes it possible to fly through the single vessels and see what's going on. So these are the actual vessels of a patient that came to our clinic, something I was doing with Professor Drexler. Now, you're looking at this and you're saying, oh, this is a neat picture, but it has clinically absolutely no use whatsoever. And I agree with you completely. But since it is a triangle mesh segmentation, it is possible to give all of these walls mechanical properties inside the simulation engine. That in turn makes it possible to use these kinds of vessels for fluid dynamic simulation. And in the future, using this kind of information for fluid dynamic simulation will help us to measure exact volume. It'll help us understand how the fluid dynamic is changed with different medications and with different diseases. So to sum up, a direct OCTA of the choroid is not practical due to all of the projection artifacts. It just can't really be done at this point in time. Indirect visualization of the choroidal vasculature is possible in the structured component of the OCT data set. But since this is not OCTA, since it's not showing flow, it's showing just the structure, I suggest that we don't call it OCTA of the choroid because it's misleading. So I propose that we call this Enface choroidal vasculography, or CVG. Obviously, right now the clinical relevance needs to be evaluated. We need to look at this as in different diseases and compare it to ICG. But in the end, I think that this could be a valuable tool for us that in certain diseases could make the need for an ICG less necessary. Thank you for your attention.